Welcome to the final video of our Introduction to Psychology. In this video, we will talk about research methods and design. In the previous videos, we talked about psychology as a science. Now that we have a mindset about how to think like a scientist, let's see some of the questions that psychologists could ask. Let's go back to the famous nature and nurture debate that we have talked about before. So Galton is a researcher that conducted studies on twins. So let's see this example first. Yonghan and Yonglin, which is my sister and I, are identical twins who grew up together. Both of them studied psychology in the same university. They went to obtain a PhD in the same institution and in fact with the same supervisor. Let's see the next example below. For copyright reasons, I cannot show the real picture of Tamara and Adriana, so I used a cartoon instead. So Tamara and Adriana are identical twins who were separated at birth, so they were being adopted to different Mexican families. One day they reunited and found out that they have a twin sister when they attend the same college. Do you think the two real-life cases that I just discussed is by coincidence? Or do you think there's other things going on? So let's see what might philosophers and psychologists say. So philosophers may have different views. Some may argue that twins are born to have similar achievements. So this may be the Plato view. And some other philosophers may think that twins have similar achievement because of the environment. So compared to philosophers, psychologists may use a scientific method to try to resolve this question. So they may first form a theory and then make a hypothesis. So here is an example of a theory. So the theory is that both nature and nurture may influence identical twins' achievements, but nature may play a more important role. So they may use different observations or actual measurements to test this falsifiable prediction. The scientific method relies on finding truth by using empirical methods to find evidence. What might researchers do to demonstrate that nature actually plays a more important role in twins' achievement? In order to find evidence that nature plays a more important role in twins' achievement, researchers may examine twins' IQ scores when they are being raised in the same household, different household, or even fraternal twins. So they found that regardless of the environment, so being raised together or in different households, they found that twins' IQ scores are strongly related. So here in the brackets, we can see the R. So the value is a correlation coefficient, and it is a number between -1 and 1. So it tells the strength of relationship between the two scores. We have just seen an example of building a study using a theory and a hypothesis. So let's talk more about what is a theory. So a theory is a first idea about a phenomenon. So it could be something that you have observed in your everyday life. Not sure whether you have had a pair of twins in your class before. So imagine you are remembering a pair of twins in your class and they always got the same mark. So this simple observation can be turned into a good theory. So a good theory should be quite simple and easy to understand. And as you find more evidence through empirical methods, your theory may evolve. You might ask, what is a good theory? So a good theory should be able to open the floor to test different questions. For hypotheses, we usually use the if-then statement. So if X is true, then we should be able to observe Y. So Y would be the result. A hypothesis should be a falsifiable prediction that is based on your theory or your observation. On this slide, I have different types of theories. So let's see which of the following theories can create falsifiable hypotheses. So falsifiable means that it can be proven wrong. The first one is classical music increases intelligence. So to turn this into a hypothesis, we may use the if-then statement. If classical music increases intelligence, then we should observe an increase in midterm scores. So we can actually test this question, right? So this is considered a falsifiable hypothesis. But let's shift our attention to the final one. So we talked about the unconscious mind and Freud's analytic theory. So the unconscious mind is not testable. So we wouldn't consider this hypothesis or any hypothesis based on this theory to be falsifiable. This is an outline of the scientific process. So the first step would be to develop a theory. So a theory may start with your own experience or observation. Then the second step would be using the theory to derive a hypothesis. So a hypothesis should be a falsifiable one, and using the if-then statement. Then the third step would be to gather evidence through different empirical methods. Lastly, you should be able to find supporting or refuting evidence toward your theory. Here I would like to point out that results can disapprove a theory but never prove it. It's because we don't know when or whether we will find results that are against our original theory. Animals are difficult to study, so for empirical method, we should always set aside a set of rules or definitions in order to make an observation or explanation. A common way to gather evidence in psychology would be observation. This is to use your senses to learn about the event. However, it is subject to different biases, and observer bias would be a significant threat to the validity of the experiment. Consider this example. If the observer is testing whether the happy pill on the image that he invented is effective, he could be biased when he expected it to be effective and rated the participant as becoming happier after taking the pill. We just covered biases among the observer, but in fact, participants can also create certain biases, known as demand characteristics or participant demand. This is when participants behave what they think they should behave. It could be in a socially appropriate manner or not. Then we also have the placebo effect. So imagine yourself getting a dosage of a medicine. You might automatically think that you are getting better after receiving the pill. How can we eliminate these different biases in our study? We also call it a confound or noise. You could use a single or double-blinded observation. This is to hide the true purpose of the study from the observer and from the participant. Also, you could use a naturalistic observation approach, so studying the behavior in real-world context. These different methods can help increase the ecological validity of your results and help you generalize the results to your everyday life context. Another way to gather evidence would be through measurement scales and survey. Same as observation, you should have a clear operational definition of what you are assessing. For example, if you are measuring weight, you should define the weight measurement by kilograms or perhaps pounds. No matter what measure you choose, the measure should be reliable and valid. What we mean by reliable here is that it's able to produce the same results. For example, if you had a weighting at 2:20 p.m., and then 2 minutes later you did another weighting on the same scale, your weight shouldn't change too much. And for validity, it's a measurement tool that's measuring what it is supposed to measure. So if you want to know your weight, you shouldn't be measuring it in centimeters. This diagram shows reliability and validity. What we want to achieve would be the bottom right one. There are many other ways to collect information. For daily diary method, participants may complete a questionnaire about their thoughts, feelings, and behavior at the end of the day. An electronic activated recorder has been used to study sounds that participants make. In the past, it has been used to study how talkative people are. And for daily physiology, we can use blood pressure or heart rate to measure participants' physiological responses. And here I'm wearing a device. It can also be used to check physical activity. Remember at the beginning of the class, I had some volunteers eat a snack for me, but I didn't tell you the purpose. So this is to demonstrate that sometimes research will hide the true purpose from participants. However, I would like you to know that deception is sometimes unethical in real-life research settings. Imagine I was a researcher trying to study this question. Does eating a snack during class increase performance on a quiz? So I had some volunteers had a snack, so it will be the experimental group, and the students who didn't have a snack is in the control group. And then our outcome variable will be measuring the performance on the quiz. The quiz was done to collect information about our outcome, so whether there is an increase in performance on the quiz. So in class, in fact, we found that there was no difference in quiz performance between those who had a snack and those who didn't. In this experiment, we used observation to form a conclusion. This is based on inductive reasoning, so finding support to our conclusion based on evidence. There is also another way to draw a conclusion. It's called deductive reasoning, using a general principle to form a conclusion. So for example, a dog is an animal. So a Snoopy in the picture are my Snoopy dogs, which is also a type of dog, should be an animal as well. The key takeaway in this slide is to say that it's totally fine if you didn't find support to your hypothesis. So this can open the door for other people to try the same study again, but under different settings, or replicate the study among different students or different populations. We want to reduce the file drawer problem in research. So this is selective reporting of significant findings and then hide the non-significant findings. As I mentioned earlier, results can disprove a theory, but we cannot prove anything in science. It's because we are always looking at the probability of associations. So in studies, we will use a value called p-value to understand the significance of the result. So we often set the value at 0.05. So we will say that if the value is smaller than 0.05, there is less than 5% chance that the results occur by chance. Now that we have collected data, we will learn how to interpret the results. So we could look at the spread of values by looking at distributions. So here is a graph. On the x-axis would be the scores on the quiz, and for the y it will be the number of students that were in the snack group and the no snack group. Depending on the spread of values, the distribution can take on any shape, but the most common one is called the normal distribution, where most values lie in the middle. So here we can see that the bell-shaped curve in red is the snack group with a normal distribution. And now I have characterized the no snack group to be a positively skewed distribution. You can see the one in black, where most values lie on the left side. And I now added in a new group called the drink group. It's negatively skewed, so most values are on the right side, so meaning that they performed better on the quiz. In addition to plotting the values, we could also look at the numbers directly and even do some simple math to understand the spread. The mode will be the most frequently observed number among the list. So here we have a list, 8, 3, 6, 9, 3, and 1. The most commonly appeared number would be the number 3. So this would be the mode. And for the mean, we could sum up all of the values and know what is the average. So here we get the number 5 as the average. Apart from the mode and the mean, you may wish to identify the middle number of the spread of values. But before we do that, we will need to reorder the number of the list first. So we will enter the number from the lowest to the largest one. And then one by one, we can cross off the values and then identify the average among the two middle values. So here we get 4.5 as the median. From this figure, you can see that in a normal distribution, the mean, the median, and the mode all have the same value. But when the distribution is skewed, you can see that these values doesn't remain the same. Now let's talk about how we could understand the variability of numbers. So the range will pick up the highest number and then minus the lowest number. So in this list of numbers, the largest number will be 9 and the smallest number will be 1. So 9 minus 1 equals 7. So this will be the range. And we will also look at standard deviation. So it tells the difference between a set of scores and the mean. So this is a common idea of the IQ score. So it has a mean IQ of 100 and then a standard deviation of 15. So when we say that you have an IQ score of 1 standard deviation above the mean, it means that you will have an IQ score of 115. Moving away from understanding the central tendency, we could also look at correlation. So correlation tells the strength of association between two values. So are identical twins' IQ scores strongly related to each other? Correlation gives us two information. One is direction and the other is strength of relationship. For direction, it could be positive or negative. For positive correlation, both values will go up together or decrease together. And for negative direction, when one values go up, the other will go down. And for the strength of association, the values lie between -1 and 1. So values closer to 1 means that the relationship is stronger. On the left and middle figure demonstrates a perfectly strong correlation, which is quite uncommon in real life. And on the right side, it shows a weak correlation. You can see the dots are scattered, so it has a correlation of around 0.1 to demonstrate this. Once again, the values will lie between -1 to 1. So the negative or positive value just tells us the direction of the relationship. And for the strength of relationship, the number closer to 1 indicates a stronger relationship. Researchers are always hoping to find cause and effect relationship. However, certain study designs doesn't allow us to understand causation. Correlation only tells us if there is a significant relationship between two variables, but we don't know what variable precedes what, because there's always the possibility of third variables or confounding variables that we have talked about in the past. So we don't know if eating a snack directly influences performance because of the Z variables listed here. So the Z variable can contain a lot of uncontrolled factors, such as the amount of sleep you had last night and whether you are actually paying attention in class. These different confounding factors doesn't allow us to understand the cause and effect relationship. It is our goal to understand cause and effect relationships. But how can we achieve this? We will talk about this. In an experiment where we can control for variables, it is a way for us to establish a causal relationship between variables. So in an experiment, we may identify the independent variable. So this will be the variable that we are controlling for or manipulating. And then the dependent variable will be the outcome variable that we are trying to assess. So we want to know whether changing or controlling the independent variable will lead to a change on the outcome. Now let's design an experiment together using bubble tea as a manipulation. So we want to know whether drinking bubble tea, which is our independent variable, will change our stress level. So stress will be the outcome variable, the dependent variable that we are measuring. In this experiment, before we randomly assign participants to the experiment or control group, we will first assess their levels of stress to begin with. And then we will need to randomly assign them into two groups. So the random assignment is just like tossing a coin. We don't know which participants will belong to which group. So for the experiment group, we will have them drink bubble tea with pearls. And for the control group, we will have them drink regular milk tea. After they have their drink, we will assess their stress levels again and check whether our manipulation, which is controlling for eating the pearls or not, can help them reduce stress. In an experiment, it is different from correlation because we do have manipulation. And then we also have a component of random sampling or random assignment. So participants have equal chances to be assigned to the pearls group or the group with only milk tea. Random assignment can ensure that participants have equal chance of being assigned to either group. And by this way, we can get a very representative data and then minimize differences between groups. In this video, we have talked quite a lot about different research methods and design. And as a scientist, we are always eager to answer different questions and do research. But before we do that, it is important that we follow ethical considerations. So a research study needs to get approval from the Institutional Review Board. And we need to ensure that we don't cause too much harm to participants. So before we launch a study, we need to get consent from participants. So they need to know and agree that they are involved in research and have the choice to decide whether to take part or not. And they can withdraw the study at any time without any penalty. We also need to ensure that information collected from them shouldn't be made public without their consent. For protecting participants from harm, it is our responsibility to ensure that they are not caused any long-term physical or mental damage. And finally, deception in studies can be used, but we also need to debrief participants when they end the study. This final slide here are examples of famous unethical cases. So for the Tuskegee experiment, men with syphilis were denied treatment, and this was done to observe the progression of the disease. It is considered not ethical today. And for the final two, the Stanford Prison Study and then the Milgram Study on Obedience, these both caused significant distress and mental trauma, which is also not considered ethical in nowadays.